Our sun won't live forever. In billions of years, it will transform, expand into an enormous red giant, and swallow the Earth. Humans will be long gone by then. But what if this process happened now, while we were still alive? What would our planet look like if we were here to watch it? This is a world we can barely imagine. The story of what happens to our planet as the sun turns into a red giant and we struggle to live in the aftermath. Our closest star is a giant ball of glowing gas, more than 1.3 million kilometers across. The sun is so large that 1 million Earths could fit inside it. But its size is just one astonishing aspect of our sun. Inside its core, hydrogen atoms are constantly smashing together. Every second, these collisions produce more energy than 2 billion large nuclear plants could generate in a year. The light and heat created here warms our planet and gives life to our world. But the fuel inside the sun won't last forever. Eventually, the hydrogen will run out. We won't be here to see it. The sun's life spans billions of years. But what if we were? What if our planet, as it is now, with our cities and our population, had to deal with a sun that began to age rapidly? If we were able to jump forward billions of years at a time, what would we see? How long could we survive? Imagine that this experiment begins today. It's an ordinary summer morning, but overnight, the sun aged millions of years. There's more light, more heat on our planet. Up close, it seems much the same, but the sun is actually producing much more energy than it does today. As it consumes the hydrogen that powers it, the core of the sun becomes smaller. As the amount of hydrogen decreases, the core is compressed. And like rubber balls bouncing inside a box that gradually gets smaller, this increased pressure means more hydrogen atoms collide. The sun creates more energy, and the Earth is hotter. people in Manhattan will face temperatures that peak at more than 55 degrees Celsius. The average global temperature has gone up by 20 degrees. Cities in Australia and Asia have temperatures that soar past 60 degrees. From Egypt to England, no corner of the world is safe. Even the coldest places on Earth are much warmer than usual. In Greenland and Antarctica, snow and ice are beginning to melt. The changes here will affect the world. It would take years, but temperatures this hot would cause all the ice at the North and South Poles to melt. The huge ice shelves of Antarctica and Greenland would slide into the sea. Sea levels around the world would rise by more than 60 meters. The world would be devastated. Manhattan and coastal cities around the globe flood. San Francisco, Los Angeles, Miami, and most of the rest of Florida would be overwhelmed. In a world with too much sun, there is also too much water. Under our rapidly aging sun, cities that weren't flooded wouldn't work like they used to. Jumbo jets strain to take off in the baking heat. Their wheels remain on the ground far longer than they would at normal, cooler temperatures. Warmer air is thinner than cold air. The molecules are more active, literally further apart. To create the same amount of lift in warmer weather, jets have to travel faster. But the thin air robs the engines of power, making it harder to produce thrust. Jets would strain to lift off, but the heat could produce disastrous consequences. Cities grind to a halt, and the heat isn't letting up. Crippled by overuse, air conditioners stop working. Long stretches at 55 degrees, and the power grid can't handle the load. Overheated cities struggle to keep the power coming. Around the world, people are overwhelmed by the intense heat. Usually, we get rid of extra heat by increasing blood flow to our skin. That's why it turns red when we're overheated. The hot blood is cooled as our sweat evaporates. But when the temperature outside is above 37 degrees, it's much harder to cool down. Our body temperature starts to climb, and our brains can't cope with too much heat. If our bodies get just 3 or 4 degrees hotter than normal for an extended period of time, we can suffer permanent injury or death. Regular temperatures of 55 degrees are hard for us to handle. It's a real danger. Several years ago, excessive heat killed more than 500 people in Chicago. During a 5-day stretch, the temperature reached as high as 41 degrees. But this heat wave is permanent. A brighter sun has shattered our world. And soon, the planet will look stranger still. During the course of its life, our sun will eventually burn through the hydrogen fuel that powers it. It's a natural life cycle that will take billions of years. In this experiment, we're speeding up that aging process to see what effects it might have on the Earth. Overnight, the sun has aged another 5,000 years. It's still 20 degrees hotter than it used to be. Temperatures that would flood cities like Manhattan. But other cities are transforming in different ways. Bamboos and long grasses are taking over where evergreens and maples used to be. If these conditions persist, cities like Chicago and Toronto will have foliage like Southeast Asia. Around the world, the climate is dramatically different too. In the intense heat, water is evaporating faster than ever before. Immense amounts of water are sucked into the sky. Tropical storms lash the planet. But even though there's lots of water, the rain is actually contributing to the death of some plants. Part of the reason can be found in the mountains. Here, the pounding rain causes massive erosion. As new rock is exposed, minerals start to bind with carbon dioxide. Over thousands of years, it's stolen from the atmosphere. But plants need carbon dioxide to breathe. Some plants, including bamboos, absorb carbon dioxide incredibly efficiently. In this hotter world, they're thriving in new locations. But other plants normally found in the northern hemisphere aren't adapting well. Maples, oaks, and evergreens struggle to deal with the dramatic change in climate. The rain that's changing the planet normally cools us down, too. We're one of the best animals in the world at regulating our temperature. Water can help us shed heat. It literally takes it away from our bodies. But in humid 55-degree weather, it's getting hard for us to get rid of our sweat. Under such extreme conditions, our bodies can lose nearly 4 liters of water an hour. at the limit of our endurance. And the heat won't let up. To make matters worse, the concrete and steel of a big city concentrates the heat. Cities can be more than 4 degrees hotter than the countryside. To survive in such a hostile world, there would be an enormous migration to the countryside, where the temperatures are slightly cooler. In the old world, this used to be a fruit orchard, helping the United States grow 150 million bushels of apples a year. But like the other plants in the Northern Hemisphere, these apple trees are not doing well in this new climate. It's just too hot for the plants to grow. It would be difficult for us to harvest the fruit in any case. Working in such intense heat quickly raises our body temperature to dangerous levels. The sun is on a relentless march to becoming a red giant. But before it gets there, the heat will build. In the next stage, we'll be wiped from the surface completely. This is a world where the sun is nearly 2/3 of the way through its life. It's something that won't happen for 3 billion years. But in this experiment, we've sped up the aging process to see what effects the sun's old age would have on Earth. Hydrogen used to make up most of the sun's core. Now, it's severely depleted. But even though there's less hydrogen, the sun is actually hotter. As the amount of hydrogen decreases, the outer layers of the sun exert growing pressure, forcing the hydrogen that remains to fuse more and more quickly. It's a doomed cycle that will end in the sun's death. If the Earth we live on now was orbiting this aging sun, the increased brightness would seem like less than the difference between a 60-watt bulb and a 100-watt bulb. But it's not the brightness we react to as much as the heat. There are no longer seasons as we once knew them. Around the world, the temperature reaches past 100 degrees, hotter than the boiling point of water. Humans simply can't survive in this incredible heat. The liquid on our eyes would evaporate quickly. The severe heat would blind us. Our lungs are filled with alveoli, delicate membranes that absorb oxygen. They can't handle the 100-degree air for long. The heat would suffocate us. It's not the under siege. The magnetosphere is an invisible field circling our planet, which protects us from blasts of solar radiation. But this hotter sun is producing more energy than ever before. Like a shield absorbing too many blows, the magnetosphere begins to weaken. More solar radiation gets through to the planet's surface. Exposed skin is quickly destroyed. The only place humans can survive this hostile world is under. Here, ragged remnants of the population are shielded from the vicious UV radiation and crippling heat. But we can't burrow too far. The temperature rises over 8 degrees Celsius for every 300 meters down. We're literally trapped between the deadly breath of our star and the internal heat of our own planet. If we want to explore the surface, we can't go unprotected. Specially modified spacesuits are a possible solution. Designed to battle the sun's searing heat, these suits come with their own internal cooling system and oxygen supply. The suits are white to help reflect the tremendous heat. But on this strange planet, anyone wearing it will have to struggle with the suit's weight, more than 45 kilograms. It's the only way to survive on the surface of the planet, where temperatures continue to climb. But the world that we would see is radically different from anything humans have ever been exposed to. Temperatures are now over 150 degrees. Cities would be devastated by the searing heat. They're baking dry. Water would evaporate far more quickly than it does under our present sun. Water levels all over the globe are falling. The sun is literally boiling water off our Earth. The surface of the planet as hot as a stove. Manhattan will no longer be an island, but a city on a barren hill as the water of our planet evaporates. Concrete and steel canyons that we built over hundreds of years are now deserted. Even water hidden in the shade of the sewers begins to evaporate. Doors begin to stick shut. The intense heat has forced the metal to expand. While open water is evaporating, bottled water can still be found. Simple physics is keeping it safe. As the water heats, pressure increases inside the bottle. That growing pressure actually raises the water's boiling point. Even at 150 degrees, this water won't boil. Yet. Cans of soda and other carbonated drinks suffer a different fate. Incredible heat is building up inside these cans. As it does, CO2, the gas that gives pop its fizz, is being forced out of the liquid. As the gas inside grows, the pressure is eventually too much. coastlines around the world would look nothing like they once did. More and more of the water that forms the oceans would disappear. Half of the water in the Pacific Ocean, the world's deepest, would be gone. And the water is hot. The average surface temperature of the oceans used to be about 17 degrees Celsius. Now, it's rising rapidly. Even hardy creatures like cockroaches can't survive. They don't have lungs and can live for weeks at a time without food. But as they venture into the sun, they would be killed, overwhelmed by the heat. As tremendous bodies of water burn off into the sky, the Earth's climate continues its transformation. More and more water is evaporating and condensing. Clouds stretch higher and higher into the sky. As the intense sun heats up the planet, storms get increasingly large. Megastorms, hundreds of kilometers across, lash the planet. If temperatures keep climbing, the air would eventually become too hot for the rain to hit the Earth. It would evaporate before it ever reached the ground. For now, the enormous banks of clouds reflect some of the sun's heat, but ever-rising temperatures on Earth cannot be stopped. Deserts would take hold around the world. Even the bamboos and grasses which thrive in less extreme warming are overwhelmed. Plants can't survive the tremendous heat. The death of plant life helps make the brutal conditions on Earth even worse. As the plants and animals die, they release carbon dioxide and water vapor into the sky. Both of these gases are part of our thermostat. They helped trap heat on the Earth, keeping it warm enough to sustain life. But now, as plants and animals rot and water evaporates at an astounding rate, it creates an intense greenhouse effect. Too much carbon dioxide and water are being released. Our thermostat is broken. It's more than 150 degrees on the surface of the planet and climbing. But some life lasts longer than others. Cyanobacteria would be among the final living organisms on the planet. Even in hotter water, this colorful algae sucks in carbon dioxide and water to live and produces oxygen. As the dark curtain of bacteria grows across the ocean, it blocks the sun over large areas. And no sunlight means there will soon be no life. of raging storms, where humans would be struggling to survive, one of the most important necessities of life is disappearing. With the death of plant life, there's less and less oxygen in the air. Huge amounts of new water vapor also lower the concentration of oxygen. Normally, the air around us is about 20% oxygen. Under these conditions, it would fall to less than 10. It's not enough for us to breathe, but it's also not enough to sustain fire. While lightning lashes the planet, fire doesn't burn. For now, even though lightning smashes down, our buildings can survive. But worse is yet to come. What's left of our planet is going to change even more dramatically. Our sun is aging rapidly, marching inevitably to its death. In this experiment, the sun's life cycle has been sped up tremendously. This is the sun as it would be 4 billion years from now. The hydrogen that's left in the sun's core is under tremendous pressure, crushed by the weight of the outer layers. Hundreds of millions of tons of hydrogen are fusing together every second. The Earth, as it is today, revolves around the sun, but it's an Earth we can barely recognize. On the surface of the planet, it's now 370 degrees and rising. It's too hot for us to survive. Even the most sophisticated suit can't protect us from the blistering heat. We can't survive underground either. At these temperatures, human life on Earth is finished. Every last drop of water on the planet is evaporating. Oceans are becoming vast, salty deserts. As the oceans vaporize, Earth is shrouded in clouds which reflect the sun's rays. But that doesn't make it cooler. Just as cloudy summer nights are warmer than clear ones, the heat is trapped in this gas envelope. But heat isn't the only punishing problem. The air pressure on 270 times what it once was. If humans were on the planet, it would feel like every square centimeter of our body was being crushed under the weight of thousands of kilograms. Eventually, even pressurized containers are destroyed, crushed by the Earth's enormous atmosphere. But even highly volatile liquids like propane and gasoline still can't burn. In these conditions, there's not enough oxygen to sustain flames. But the extreme heat is more than enough to begin melting what we've left behind. Polyester and plastics turn into a molten mass. The extreme temperature also marks the death of anything made of concrete. Concrete has water trapped in it from when it was mixed and poured. But now, in over 370-degree heat, this trapped water evaporates explosively, turning the concrete brittle and dusty. Inside the concrete, the metal rebar, which gives it added strength, is also expanding in the tremendous heat. Combined with the evaporation of the moisture, the effect is dramatic. Some ancient monuments are better able to withstand the tremendous heat. Even 370 degrees isn't enough to damage the limestone of the pyramids. The enormous sentinels of Stonehenge are made of sandstone. They wouldn't melt yet either, assuming they were still around. But these incredible temperatures aren't stable. In fact, 370 degrees isn't anywhere near the most extreme the world will see. The greenhouse effect gets worse. Temperatures shoot up toward 1,300 degrees. The last radical increase in temperature is the beginning of the end. As temperatures skyrocket, more and more of the water vapor circling the planet escapes our atmosphere and travels into space. Water that makes up the clouds is bombarded with UV radiation from the sun. The radiation splits the hydrogen off from the water molecule. The hydrogen escapes to space. The oxygen remains behind. As it does, the world is remade. About 5% of the Earth's crust is made of iron. As the oxygen returns, the iron begins to rust. The planet begins turning red. As the oxygen levels climb again, the enormous temperatures spark a deadly cycle. There's enough oxygen for fire to return. Anything that survived now burns. Even without the fire, the limestone of the pyramids now crumbles. And the sandstone of Stonehenge melts. The heat is too great. The last artifacts of our existence return to the planet. Earth is now a scorched, rusting world. The sun is just 40% brighter than it once was, and what's left of the world is consumed by fire. The sun that gave us life has now scorched the planet bare. This is the Earth, if we put our planet as it is now, billions of years into the Sun's future. In this experiment, our Sun has aged, and we've tried to live under the light of a hotter, brighter star. Our cities are gone, our manufactured world destroyed by the blistering heat. Any kind of life on our home planet has become impossible. Now the Sun is more than 6 billion years older than it is today. It's time for the end, not just of life on Earth, but of the planet itself. Deep inside the Sun, the last of its hydrogen fuel is consumed. What remains is a core of helium. It takes enormous pressure and heat to make the helium fuse. But now, the immense force of the Sun's outer layers bears down, and this fusion begins. The powerful ignition actually starts to propel parts of the Sun out into the galaxy. Our planet is scorched smooth. Its relentless growth has brought the Sun just a few million miles from Earth. It has already swallowed Venus and Mercury. Now the rising sun completely fills the horizon on what remains of our planet. Over 200 times bigger than it once was. Humans would only be able to witness this extraordinary event if we had somehow escaped the Earth and we're observing our planet from afar. Perhaps Jupiter's moon, Europa. It's always been outside the habitable zone of our solar system, too cold to support human life. But the red giant has changed that. Temperatures reach habitable levels even at the far edges of our solar system. But Earth looks nothing like it used to. There are no signs to indicate it could have ever sustained life. And then, the final act. The massive outer edges of the Sun begin to slow the Earth's orbit. Our planet is now a fireball, burning up like a meteorite. In a blast of unimaginable heat, we're swallowed by the Sun. This has been an experiment. As our sun ages, it will slowly become hotter and larger. It will eventually become a red giant and transform our solar system. None of this will happen for billions of years. But even now, our life and the life of our planet are balanced precariously. The Earth is just warm enough, just bright enough for life to thrive. We live today, as we always have, at the mercy of the sun.